So in our example number 5, now we were given a 2 megagram car being towed by a winch. If the winch exerts a force of tension T is equal to 100 times quantity S plus 1 Newton on the cable, where S is the displacement of the car in meters, determine the speed of the car when the displacement is equal to 10 meters starting from rest. Neglect rolling resistance of the car. Okay, so we just neglect here the rolling resistance. There is no forces resisting the car. So what do we have? We were given the mass. The mass is equal to 2 megagrams, or that is equal to 2 times 10 to the 6 grams, or simply 2,000 kilograms. And then what else is given? We have a tensional force that is equal to 100 times S plus 1 Newton. Okay, take note that the force is not constant, then we cannot apply the constant kinematic equations here. What else do we have? Determine the speed of the car when S is equal to 10 meters starting from rest. Okay, so starting from rest, so at distance or from the origin at S is equal to 0, its velocity or its speed is equal to 0. And then at S is equal to 10 meters, we are tasked to find the velocity. Neglect our rolling resistance of the car. So again, our tension is formed here. This is T. Okay, without actually in this one or in this type of problems where the friction is not present or if it is not inclined, then automatically we can try to consider the forces acting along x-axis or along the horizontal. We don't need to draw the FBD, but we know, we just write summation forces along x is equal to the mass times the acceleration along x. That is positive along right. So the forces along x, we have a tension, and that's all. It's equal to mass, that is 2,000 kilograms times the acceleration towards x. Our tension is equal to 100 times s plus 1. It's equal to 2,000 times the acceleration. Now, if the force is not constant, we refrain from substituting the value, actual value of the, let's say for this one, we have the distance or displacement is equal to 10 meters. No, before we try to solve for the velocity, we just get the equation of the acceleration is a function of distance. Then we will obtain 0.05 times s plus 1. And this is the acceleration as a function of distance. Next, of course, it is very obvious that we are going to use this one. VdV is equal to AdS because we are asked to find the speed of the car. So we have the VdV is equal to 0.05 times s plus 1. So integrate that. The lower limit for the velocity is 0 because it starts from rest. So it's final velocity. Initial or the lower limit along the displacement, that is 0, starting from the origin to 10 meters ds. I don't forget the dsu. So the left side we have 1 half v squared to be evaluated from 0, from initial velocity to final velocity. And on the right side we have 0.05 times 1 half s squared plus s to be evaluated from 0 to 10 meters. So we have 1 half v squared minus 0 is equal to 0.05 times 1 half s squared. So we have 10 squared plus 10 minus 1 half times 0 plus 0. Of course, it's already automatically 0. And then we have 1 half of v squared equal to 0.05 times 60. And finally, we can solve the velocity of this one as equal to 2.449 meters per seconds. And this is the solution for our problem number 5. So this is very simple, no? If you notice that there is already no kinetic friction or any resisting force acting on the along the acceleration of the object, then we can neglect the forces along y. Now we can to siya pasagdan, and then we just solve for the forces along x, and then here this is there is no rolling resistance of the car, and then remember that our force is not constant. That is a function of or displacement. It increases as as it is being displaced or as it travels. So therefore we cannot apply the constant kinematic equations, and we try to apply the derivation or the integration to solve what is being asked.